Hi, thank you for joining. Thank you for liking and sharing this video. Thank you for subscribing to the YouTube channel. In this video, I'll be showing you how you can use high school maths to solve a civil engineering problem. My name is Percival Pagati. I'm a data scientist. So what I want us to do here is design a bridge as a civil engineer would do, just using high school maths. But for us to understand that how we can actually design a bridge like a civil engineer, we need to understand two topics, high school topics. You need to understand quadratic equations. You need to understand derivatives. So what I'm going to be doing is I'm going to give you a full revision on these two topics, quadratic equations and derivatives, and then give you a problem definition and also give you a solution. So this is a problem definition. I'm not going to read it right now. You can pause the video yourself and read it, but we're going to read it later in this video. And if you think you can actually answer this question yourself, feel free to pause this video and start answering this question. I really want to know people who have tried these questions. Yourself, please feel free to do that. Pause this video and answer this question, or otherwise we can just go through it together. Okay, let's go. So firstly, I'm gonna give you revision on quadratic equations, revision on derivatives. So what are the quadratic equation? So when you talk about a quadratic equation, right? A quadratic equation, this is just some other people they can call it a parabola. You can say parabola, or others they call it there's so many names, but most of the popular names is just quadratic equation or parabola. So a quadratic equation, if I may draw a picture of a parabola or a parabolic shape, will look like this. So anything that looks like this is a parabola or a parabolic shape, right? And a quadratic equation, it's a math term that you can use, but parabola is a geometric term that you can use just to show how it looks like. So a quadratic equation, if you have to write a mathematic term of the shape, it will look like this: y is equal to ax squared plus bx plus c. And these numbers a, b, and c, they mean something in real world, and it's something that I wanted to talk about. Y and x, we know these are independent and dependent variable. X is an independent variable. Y is an independent variable. X is an independent variable. Y is a dependent variable. But what I want to highlight here is A. A is a variable that we use to show the shape of a parabola, right? So this A determines the shape. Let me just write it, maybe shape. Determine the shape of a parabola. What do I mean by that? So if A is negative, you're gonna have this shape. So in your equation, if A is negative, you're gonna have this shape. That's guaranteed. If A is positive, it's guaranteed that you're gonna have this shape. Okay, so if A is negative, you have this shape. You have a parabola facing down. If A is positive, you have a parabola facing up. And B, we'll talk about B probably later, but for high school students, don't need to understand what B is. What you need to know is B is just an arbitral number that you need to calculate your parabolic equation. But what is significant here is C. C is very significant. So C is your y-intercept. What does that mean? It means that when x is 0, y is equal to c. That's what this means. So y-intercept, let me just use a different color. Y-intercept means that when x is 0, y is equal to c. So when x is 0, y is equal to c. I mean, we can actually see that in this equation. So if you have y is equal to a x squared plus b x plus c, when x is 0, so when there's x, you put 0, you're going to have a 0 squared plus b times 0 plus c. So a times 0 squared, that's 0. B plus times 0, that's 0. Plus c, so 0 plus 0 is 0. Plus c, that's c. So y is equal to c. When x is equal to 0, y is equal to c. That's very important. So when you see c, you see a y-intercept. But I'm going to show you what is a y-intercept in the real world, right? How does that look like? What is an intercept in the real world? But that basically means that when the x value is 0, or the independent variable is 0, then the dependent variable is c. That's basically what this means. When an independent is 0, the dependent variable is c. That's a y-intercept. Okay, so essentially what we have learned now is these two babies here. So we have learned that a parabolic equation looks like this, and we know the parabolic shape, how they look like, and we know if that A controls the parabolic shape, can go look face down or it can face up, whether A is positive or whether A is negative. And we've learned about the y-intercept. But parabolas, they also, exist in real life, right? So you can see parabolas everywhere, everywhere. The famous McDonald logo, those two M's, there's just two parabolas facing together, right? You can see that in real world, two M's facing, it's not even M's, those are just two parabolas standing facing against each other. And that's one of the nice things about parabola shape or parabolic shape, is they are appealing to the eye. They are very appealing to the eye. Parabolas in its nature, they help to stabilize structures. That's very important to understand. That's one of the reasons why architects or civil engineers will use parabolas, besides just because they look beautiful, but also they help to have a stable structure, right? You see parabolas in nature as well. The rainbow, you know what I mean? This rainbow portrays a parabola. Dolphins, when they jump up and down out from water, inside the water, they do that in a parabolic shape. They show a parabolic shape. So even if when you're playing sports, when you throw a soccer ball up to the end, comes back, it's gonna portray a parabolic shape. Whether it's soccer, whether it's tennis, whether you are playing a basketball, a volleyball, netball, for you to able to have a good shot, you need to have a sense of your environment and how parabolic shape look like, or how a quadratic equation will look. Not necessarily even mathematics, right? Not the quadratic equation itself, but just having a clear understanding of a parabolic shape. You can able to estimate, if you throw your ball this high, it will able to turn in this point and able to shoot and have a good shot. So that's very important. So parabolas, they exist everywhere. Please check out parabolas wherever you go. They exist, and just see how beautiful they look, and see how other people are using parabolic shapes to in their structures, in their everyday of life. It's soccer. For you to have a good free kick, you need to able, in playing soccer or football, you need to able to understand parabolas, and have a good sense of parabola, and then you're able to really good have a good free kick. So yeah, there's so many applications, so many ways where you can actually see parabolas. But what I want us now to do is, since we have an idea of parabolas and how people are using parabolas, how you can use parabolas, I'm going to show you an example on how we can actually use parabolas and even calculate quadratic equation of a parabolic shape, right? Especially in this case, we're looking at a bridge, how to design a bridge like a civil engineer. Right. So what I want us to also discuss here, beside just quadratic equations, so we've covered quadratic equations, but I want us to talk about derivatives. Okay. So how derivatives and quadratic equation come together, and I'll show you just now. So a derivative, what you need to know really with derivatives is this. So if you have y is equal to a is just a constant number, any number, x, again, independent variable, power b, right? If you have y is equal to a times x power b, if you have to find a derivative of y, it's going to just y and just a dash there, or other people they just say dy dx, which is saying you're deriving y with respect to x. If you have to find a derivative of y, it will be a times, or let me write it this way, it will be b times a x power b minus 1. That is how you would find the derivative of y. A times b power b minus 1, right? So let me give you good examples. So let's say you have y is equal to a x squared. What is the derivative of ax squared? That will be 2 times ax power 2 minus 1. That's how you find a derivative of ax squared, which means this is going to be 2ax power 1, and x power 1 is just x. So derivative of ax squared is 2ax. Now what is the derivative of y is equal to ax? Now a derivative of y is equal to ax, you're doing the same principle. You're saying derivative of a is equal to a, say 1 times a, so it's 1 times a power x power 1 minus 1. So 1 times a, just a, x power 0 is anything x power 0 is 1. So you have a times 1, and a times 1 is a. So a derivative of y is equal to ax is equal to a. Derivative of ax is a. Last thing, a derivative of a. A is a constant again. So a, since it's a constant, the derivative of a constant is equal to 0. The derivative of a constant is equal to 0. Two things that you need. So what you have to learn here, you've learned what is a derivative, just a general equation of a derivative, and then you know a derivative of x squared is just 2ax. Derivative of ax is just a. Derivative of a constant is 0. Derivative of a constant is 0. Now, I'm going to show you how you can then combine this knowledge. Now you know about quadratic equations. Now you know about derivatives. Then you can combine these two to somehow find certain things. So what we haven't learned about quadratic equation is what you call turning points. Okay. Let's wrap this off. Turning point, call it TP. Turning point is at these points here. So this point here has a turning point. This is a turning point. So a parabola, one of the main characteristics is they have that one turning point. Right? That's one of the main characteristics of a parabola. They have that one turning point. And of course, that turning point, because we are looking at it in a two-dimension space, a turning point has an x value and a y value. So it has a dependent value and an independent value, right? Has an independent value and a dependent value. A turning point has that x and y. So you need to be able to identify the x value of the turning point, and that's very important. It's very important for us to be able to identify the x value of the turning point. So how do you calculate the x value of a turning point? So now you have y is equal to ax squared plus bx plus c. So that is your quadratic equation. Now, for us to identify the turning point, a derivative, a first derivative of an equation, it's a way of identifying the turning point, right? So when you talk about derivatives, you are calculating a turning point. You are calculating a turning point. That's what derivative does. So when you're looking at, if you want to calculate a derivative, if you want to calculate a turning point of anything, you just have to calculate the first derivative. So you calculate the first derivative and you equate that first derivative to 0. That's what you do. Calculate the first derivative, equate it to 0, and solve for x. And that x is the x value of the turning point. So how do you calculate the x value of the turning point? You find the derivative, equate it to 0, and solve for x. And that x value is the x value of the turning point. Now let's do that. So we say we find the derivative of this equation. Why are we doing this? Because we're trying to find the x value of the turning point. Find the derivative of this equation. So what is a derivative of ax squared? A derivative of ax squared is 2ax, right? And what is a derivative of bx? Derivative of bx is b. What is the derivative of c? C is a constant, so the derivative of c is 0. Now what do? We take the derivative equated to 0, so we have 2ax plus b is equal to 0. Then we solve for x. So solve for x, just take that b, put it into your right hand side, becomes negative. So you have 2ax is equal to minus b, and then you divide by 2a on both sides. Therefore, x is equal to minus b over 2a. And I'm pretty sure that you've seen this before. This is how you would calculate the x value of the turning point. The x value of the turning point is equal to minus b over 2a. And this is why that I say I will talk about b on later on. So the b helps us to identify the turning point of a parabolic equation. That's basically what b does. B and a helps us identify the turning point of the equation. So x is equal to minus b over 2a. And this is how you do it. It's either you can remember this yourself, but if you don't remember it, just know derivative is beneficial for you to understand derivative. And then from there, you can just find the first derivative equal to 0, and from there, solve for x. And then your x is equal to minus b over 2a. That is the x value of the turning point. And then from here, to find the y value of the turning point, then you have to substitute that x back into this equation. So the y value of the turning point is, I'm running out of space here, so let me just rub this off. So the y value of the turning point, we have y is equal to ax squared plus bx plus c, and then we have the x value of the turning point is minus b over 2a. Now the y value of the turning point is where there's x in the original equation. Where there's x, you just put minus b over 2a. So you have a minus b over 2a squared plus b minus b over 2a plus c. This is the y value of the turning point. And this is how you calculate the turning point. This is how you calculate the turning point. Right. So this is my revision of quadratic equation and turning points and derivatives. Now, if you understand this, we are ready to answer this question. ready to answer this question. And if you don't understand what I just shared with you, please make sure that you write your comment, and I'll able to answer your comment back. If you have more questions, for example, you are writing your homework or your assignment, or you're preparing for your exam and you have a question, just take a picture of that question, become a member on my Patreon, and post that picture there on my Patreon as a member. Then what I'll do is I'll create a video to show you how you can answer that question, right? So I'm here for you. So please use these communities. They're gonna help you do well in mathematics. All right, so let's go. So now let's go to the real life example. You've been waiting for this. So suppose you are a civil engineer, right? We are not qualified to work as a civil engineer and solve civil problems. I'm kidding. But suppose you're a civil engineer and you are tasked to design a new bridge with a parabolic shape, and the bridge must span a river that is 80 meters wide and have a height of 12 meters at the center. To design the bridge, you need to determine the equation of a parabola that represents the shape of the bridge deck. Okay, so let's visualize this. So let's say you have a bridge. Let me put it this way. Let's say you have a bridge. Let me see. So let's say this is the beginning and the end of the bridge, and there's a river flowing here, and you are asked then to design a bridge, right? And remember, you can just put a straight line here and then you're fine. But one of the reasons is very important to actually use a parabolic equation is it enables us to have a stable structure, right? So that's one of the reasons why a parabolic bridges are popular, is because they're, number one, they're beautiful. Number two, they enable the structure to be stable. Because if you have a car at the end of the bridge, that part of the car might have more stress, and then later on in the left span of the bridge, that bridge will break. But have a stable parabolic shape, whether under the bridge or above the bridge, that shape helps to actually have a stable structure that is not stressed by any mass that passes by that bridge. Okay, so let's say you have now you need to like sort of have a parabolic shape. We're creating a parabolic shape bridge, and that's basically what they want us to design. And maybe this is how your bridge looks like. This is maybe how your bridge look like. Hopefully it's a good design, maybe not. And right, so it looks good on paper. This is the road, right? Cars are passing here, and one of the benefits as well is, I mean, if you have a boat that has to pass through here and the boat is long, you can actually cut this bridge in half and put it up, right? And put it up so that the boats can pass by, which is cool. That's why parabolic bridges are famous, especially when you have like a big river that boats passes by, can break it apart, and then the bridge will pass and break it back, and then have cars pass. Right. So that's what they're telling us now. They're telling us that you have a parabolic, creating a parabolic bridge. So let's come back to mathematics. So let's go back to, let's say you have a Cartesian plane. Okay. I'm going to show you how this will look like when you have to now write a math equation. And you have your bridge, a parabolic bridge. Okay. And so let's say this Cartesian plane cut exactly at the center of a parabolic bridge. So at the center of the parabolic bridge, and we are told that this bridge is 80 meters wide, right? So meaning from this point to this point is 80 meters wide. So if you cut it half, so it's gonna be, this means that from here to here it's 40 meters, and from here to here it's 40 meters. So this is gonna be 40 meters, and this is gonna be negative 40, because we're looking at a Cartesian plane. So it's negative 40 if you're looking at a Cartesian plane. This side's or negative or positive or negative or positive, right? So positive 40, negative 40, but the distance is 40, 40, right? And we are told again that the height of this bridge from the center is 12 meters. So from the center, the height is 12 meters. So this part here is 12 meters. So we are being told this is 12 meters. So lucky us, we already know the turning point, right? So the turning point here is just 0 and 12. We already know that the turning point of this bridge is 0 and 12. The x value is 0 and the y value is 12. So we know that the height, the x value is 0 and the y value is 12, because that's where this bridge turns. Okay. And also, by the way, as you can see, this is a y-intercept. Maybe I'm jumping the gun, right? This is a y-intercept. We see it, but let me just probably write the equation down just for a reminder. Y is equal to ax squared plus bx plus c. And what did we say by y-intercept? We say y-intercept is when x is equal to 0 and y is equal to c. Right? When x is equal to 0, y is equal to c. So therefore our c, when x is equal to 0, y is equal to c, so therefore our c is equal to 12. Y is equal to c and our c is equal to 12. When x, we discussed this, when x is 0, y is c. That is our intercept. This is intercept, y-intercept. When x is equal to 0, y is c. And in this case, c is 12. Make sense? So now, what do we know in this equation? We have ax squared plus bx plus 12. Great. Now we need to identify b and a. What is a? What is b? All right. How do we do this? We need to do this. There's a couple of ways of doing it, but firstly, we need to remember derivatives. So if you find the derivative of this equation, it's gonna be, so the derivative of this is 2ax, right? What is the derivative of bx? Is just b. What is the derivative of a constant? Derivative of constant is 0. And then what do? Derive, take a derivative and equate it to 0 and solve for x. So you have 2ax plus b is equal to 0. And then your x is equal to minus b over 2a. We've already done this. But the nice thing that we know is we already know the x value of the turning point. The x value of the turning point, we already know. What is the x value of the turning point? Is 0. You already know that. So you don't have to calculate it. You already know it. So you can now come back and say, okay, great. So this is how you calculate the x value of the turning point, but we already know the value of the turning point, that is 0. The x value of the turning point is 0. So let's solve for b. So if you cross multiply, it's going to have 0 times 2a is equal to minus b. And 0 times 2a, anything multiplied by 0 is 0. So 0 is equal to minus b. And then, so therefore b is equal to 0, right? Because if you divide by negative 1 on both sides, it's going to be 0. So b is equal to 0. Boom. So now we've discovered that b is equal to 0. Now our equation looks like this. So let me just wrap this off. So y is equal to ax squared plus 0 plus 12, right? Because I mean it's 0 times x plus 12. 0 times x is 0. So we're going to have plus 12. So y, this doesn't look like y. So y is equal to ax squared plus 12. That is our equation. Now, what is our a? Now remember, I said a determines your shape. And look at our shape. Our shape is facing down. Therefore, a is negative. So a must be negative. But how do we identify the value of a? Now we know that a, for sure, a is less than 0. It's negative, just based on the shape, right? But what is the value of a? So the way you calculate this, you'll be say, all right, you have the x-intercept, right? So what are the x-intercepts? X-intercept, again, the same as y-intercept. X-intercept is when y is equal to 0. When y is equal to 0, what is your x? So you have 0, you have x and 0. So when y is 0, what is your x? In this case, this is our x-intercept. Our x-intercept is when y is 0, we have negative 40. When y is 0, we have positive 40. Those are our x-intercepts. So, meaning, when y is equal to, we have this equation, come back here, y is equal to ax squared plus 12. So when y is equal to 0, you have either positive 40 or negative 40. So you can choose one of the two. This should be fine. So you have a, where your x is either positive 40 or negative 40, right? I'll just put negative 40, you can put positive 40, you should get the same answer. So when y is 0, x is either positive 40 or negative 40. That's our x-intercept. Let me write that down. When y is 0, our x-intercept is plus or minus 40. That's our x-intercept. Okay, great. So you have 0 is equal to negative 40 squared. You can write that down yourself. So take your calculator and say negative 40 power 2. So that is 1600 a plus 12. Remember solving for a. So let's take that 12 and put it to the left hand side, become negative 12 is equal to 1600a, and then you can divide by 1600 on both sides. So negative 12 divided by 1600, that is negative 3 over 400. So your a is negative 3 over 400. Okay, that is a, which is essentially 0.0075. Okay, now, so our equation looks like this. The equation of this new bridge that we're designing is y is equal to a, we already discovered a, this is negative 0.0075 x squared plus 12. This is the equation of our new bridge. So now you can take this equation and give it to the designers and tell them, hey, for us to able to design this bridge within this river, which is 80 meters wide, and you want to have a bridge that is 12 meters tall and is a parabolic equation, it's a parabolic shape, use this parabolic equation to determine your bridge. And from there, you can able to determine a beautiful or design a beautiful bridge as a civil engineer. It's exciting. This is exciting. This is the stuff. This is why am I so excited about this work? But this is exciting, and I hope you're getting the same excitement that I'm getting as well. And so if you want to have a tutor, someone who will help you with your homework, help with your assignment, help you with anything that you need, and also have one-on-one sessions, please let me know. I'm available for assistance, and make sure that you talk to your parents and let them call me or send me an email, and I'll able to arrange time with you to help you do well in mathematics. All right. Thank you for joining. Thank you for subscribing. Thank you for sharing this video. And I'll see you in the next video. Boom.